Hi, my name is dr. Ahmath. In this video lecture, we are going to talk about the angles. The definition of the angles is the following. So the angle is the set of points determined by the two rays. So essentially, I'm going to call the first ray as the initial line or initial line. And the second one we usually call as a terminal line. And the set of points in between the initial line and the terminal line is going to be an angle. So we can measure the angles using the degrees, or you can measure the angles using the radians. So in this video lecture, we're going to talk about what is the measurement of the angles, the degrees, and how we can measure the angles using the radians. What are the relationship between the radians and degrees? And also, we're going to talk about the definitions of the reference angles, the standard angles, the acute angles, complementary angles, and so on. So first of all, let's define what is called the standard angle. So we say that, hey, the angle is in the standard position if the initial line is on the x-axis. So the standard position when the initial line is on the x-axis. So I'm going to draw the coordinate system, the rectangular coordinate system, first of all. So this is the x-axis and y-axis. So you see, so my initial line here should be on the x-axis. Okay? So that it is going to be the standard position. Now I need to draw the terminal line. And in order to draw the terminal line, I will start my position from the initial line. So I will just put my terminal line on the top of the initial line. And I'm going to just rotate this one time around the origin. Okay, so that the terminal line is also going to be here on the top of the initial line. So here I've got both of my rays here, initial line and the terminal line are here. So it appears if you just grab this terminal line and rotate this around the origin one time, this is going to be equal to the 360 degrees. So this is how we are going to measure the angles. And now the idea of measuring the angles, the smaller one than the 360 degrees, is by just dividing the 360 degrees into the portions. So let me explain you what do I mean. So let's say again, I've got the rectangular coordinate system here. I'm going to put this. It's going to be x-axis and it's going to be the y-axis. If I would just have the terminal line here, the initial line here, and if I would just rotate the terminal line, or if I would just rotate this until I will get the terminal line here, then you see, so this is exactly the half of this 360 degrees, right? So this is 360 degrees divided by the 2. So that's why this angle is going to be measured as the 180 degrees. And again, like let's try to split the 360 degrees into the 4, for example. So if you've got again the initial line here on the x-axis, and the terminal line is going to be somewhere here on the y-axis. Okay, and you obtain this by rotating the initial line up to here, and you see, so this is 1/4 of this 360 degrees. So this 360 degrees divided by 4, this is going to be equal to the 90 degrees. So we can continue doing this. So for example, if I would just get the terminal line on the y-axis, but in the opposite direction. For example, the terminal line is going to be here, while the initial line is going to be here. So can you figure out what is going to be the measurement of this angle? So you're starting from here and you're finishing here. Okay, so this is going to be 3/4 of this 360 degrees. And if you just multiply everything out, you will get 270 degrees. So you see, so we can measure the angles using the degrees when we're going to just split the circle into the smaller pieces. So you see that every time I'm rotating the terminal line in the counterclockwise direction, in the counterclockwise direction. And the natural question is it possible to obtain this terminal line by rotating the initial line in the clockwise direction? For example, can I just like rotate this in this direction as well? Or can I just rotate this in this direction, for example, like this? Or can I rotate this like this here? So it appears, yes, we can do this, but all the time when we do this, we're going to measure the angles negatively. So again, essentially, so this angle is going to be equal to the 180 degrees with the negative. So the same thing as we did before. So I'm going to just split this 360 degrees into the pieces. So one time revolution around the origin in the clockwise direction is going to be equal to the minus 360 degrees. Then I'm going to just split this into the pieces. For example, this angle here is minus 360 degrees times this is 3/4, right? So that's why it's going to be equal to the minus 270 degrees. So what about this angle? So this angle is going to be minus 360 degrees times to the 1/4. So this is going to be equal to the minus 90 degrees. So essentially, whenever we rotate the terminal line from the initial line in the counterclockwise direction, we're going to get the positive angle. So we are going to get the positive angle. And every time we need to split plus 360 degrees into the pieces. And every time when we rotate the terminal line in the clockwise direction, we are going to get the negative angles. So this is actually how we are going to define the negative angles, how we're going to draw the negative angles. And what we need to do is we need to split minus 360 degrees. Okay, so again, every time when the initial line is lying on the x-axis, we're going to talk about the standard angles. So at the same time, for every standard angle, there is a corresponding reference angle, and I'm going to try to explain you this. What does it mean? So, but before we do this, let's define something which is called like a acute angle and obtuse angle. So acute and obtuse angles. So this is just a definition of some angle. So every time when the angle is defined between 0 and 90 degrees, this angle is going to be called as an acute angle. So let's say again I've got x and y. So here is my initial line, and whenever the terminal line is going to be always between 0 and 90 degrees, between 0 and 90 degrees, this angle is going to be called as an acute angle. So the acute angle is going to be this angle alpha. So let's say, so the alpha is going to be always between 0 and the 90 degrees. And whenever the angle is way behind 90 degrees, so between 90 and 180 degrees, that angle is going to be called as the obtuse angle. So later on, when we're going to talk about let's say, the trigonometric functions, it's important for us to know what's an acute angle, what's an obtuse angle. So let's say this is the x, this is the y again. So I've got my initial line here again. So here is my initial line, and whenever the terminal line is here, here, or somewhere here, so essentially between 90 degrees and 180 degrees, then the angle, so this angle, so where I'm going to draw this like here, right? This is going to be my beta. So whenever this is between 90 and 180 degrees, we're going to call that angle as an obtuse angle. So at the same time, two angles two angles, alpha and beta. Alpha and beta are called as complementary angles, as complementary angles if alpha plus beta is equal to z 90 degrees. For example, if I would say, hey, alpha is equal to the 20 degrees and the beta is equal to the 70 degrees, then they are the complementary angles. And whenever I say, hey, so if alpha is equal to the 7 degrees, could you please tell me what is its complementary angle? You can just tell me, hey, this is going to be 83 degrees because the sum makes the 90 degrees. And the two angles, alpha and beta, are going to be called as the supplementary angles. Supplementary angles if alpha plus beta is going to be equal to the 180 degrees. And again, for example, if I would just give you alpha as the 65 degrees and the beta is going to be 115 degrees, so that their sum makes 180 degrees. And then whenever I say, hey, if the beta is equal to the 163 degrees, what is going to be the supplementary angle of this beta? You would say, hey, this is going to be the 7 degrees because their sum makes 180 degrees. Okay, so now, so you see, so every time, whenever we are going to just split this 360 degrees into the pieces, we're going to get the degrees, right? So is it possible to split even a degree into the pieces? So let's say I've got this angle, so let's assume that this is a huge circle so that you see just 1 degree. And what I would like to do is I would like to split the degree into the 60 parts. 60 parts. 60 equal parts. So I'm going to just put lots of here the lines, so essentially the 60 parts. And every of this part is going to be equal to something which is called a minute. So essentially 1 degree divided by the 60 is going to be equal to the 1 minute. We call this as a 1 minute. At the same time, every minute can be split into the 60 parts, 60 equal parts, and we're going to call this as the second. So essentially 1 second or 1 minute divided to the 60 parts is going to be called as the 1 second. And I'm going to put the 2 primes on the top of that number, so it's going to be equal to the 1 second. So essentially what I can do is I can define, if the angle is defined as 73 degrees, 56 minutes, and 18 seconds, and I would just write as, hey, so this is like a 73 degrees, 56 minutes, and 18 seconds. So essentially it allows us to measure the really tiny, tiny angles. So now let's try to do a couple of examples in order to make the calculations about the minutes and the seconds. So let's do an exercise. So let's say you're given the alpha, you need to find its complementary angle. So if alpha is equal to the 73.26 degrees, what is going to be its complementary angle? Complementary angle. So if you remember, so the beta is going to be called as the complementary of the alpha if their sum is going to be equal to the 90 degrees. So what I have to do is I just need to subtract this from the 90. So 73.26. So essentially, you see, so this angle is given in a decimal form. So essentially, it's 0.26. So what I can do is I can write down the 90 degrees as a 90.00 minus 73.26, and what I can get is essentially here is going to be 16.74 degrees. Okay, So it's not so difficult, right? So now let's say beta is given as 25 degrees, 43, oh, let me write this as a degrees, 43 minutes and 37 seconds. And if I would need to find its complementary angle, so what is going to be its complementary angle? I can't really subtract this from the 90 degrees anymore, right? Because now this angle is given in terms of this notation of the minutes and the seconds. So what I have to do is I need to write down the alpha is going to be equal to the 90 degrees minus the beta, right? And now I'm going to write down the 90 degrees in terms of the minutes and seconds. And this is how I'm going to do this. I'm going to write this as a 89 degrees. 59 minutes and 60 seconds. And then I'm going to subtract the beta from this. So I'm going to subtract the beta from this, which is going to be equal to the 25 degrees, 43 minutes, and 37 seconds. Okay? And then this is just a subtraction. So the minutes are going to be subtracted from the minutes, seconds are going to be subtracted from the seconds. And if you need the second, you can just give 1 minute to here, right? If, for example, this minute would be the second would be smaller than the white one, you would just give 1 minute to there. So the 60 seconds minus 37 seconds, it's going to be equal to the 23 seconds. So this is equal to the 23 seconds. 59 minutes minus 43 minutes is going to be equal to the 16 minutes. And 89 degrees minus 25, it's going to be equal to the 64 degrees. So this is going to be essentially the complementary of this angle beta. So this is how we're going to work with the minutes and the seconds. And then now the last thing which I would like to define here is the something which is called radians. So it appears we can measure the angles not only with the degrees, we can measure this using the radians as well. Radians. And this is very much connected with the circle. So let's say I've got a circle. So this is my circle. So what I would like to do is I would like to find out the center of a circle, and I would like to draw the initial line. Now, what I would do is I would just stay on the top of the circle and just walk, okay, on the circle. So let's say the circle has a radius, let's say 2 meters, and I would walk exactly 2 meters here. So let's say I would walk exactly 2 meters. Okay, then I would just stop and just look to the center of the circle. So I would just go to here and I would look to the center of the angle. And this angle here, alpha, is going to be equal to 1 radians. So 1 radians. So this is the measurement of the angle. So how I'm going to measure this angle. So again, so I'm going to just stay on the circle, just like walk to there on a circle exactly so the distance which is exactly equal to the radius of the circle, so in this case exactly 2 meters. So if I just continue walking so until here, for example, let's say let's walk like 4 meters, right? 4 meters. Then this angle here, so let me draw this as a beta angle, beta one. So the beta angle is going to be equal to the 2 radians. If I would just walk like a 6 meters to here, so 6 meters, I would just find myself somewhere here, right? So I'm going to be here, and this angle here is going to be equal to 3 radians, 3 radians. So you see, so if you remember, the half of the 360 degrees was measured as the 180 degrees, right? And I need a little bit more distance to here. So I can just split the radians into the pieces, right? For example, if I would just walk here, not the 2 meters, but if I would just walk 1 meter, then this angle here is going to be equal to the half of the radian, right? 1/2 radians. Okay? And again, now here you see, so in order to just finish the half of the circle, I need to walk 6 meters and a little bit more, right? And this value, it appears, so you see, so this is the 1 radians, the 2 radians, the 3 radians, and here, this is just a small portion of this radians. So this is going to be equal exactly to the roughly, sorry, not exactly, roughly 0.14 radians. Okay, so you see, so the measurement of the half a circle is going to be equal to the 3 plus 0.14 radians. So this is the half a circle, which is going to be roughly equal to 3.14 radians, right? And sometimes we just call this 3.14 as the pi, okay? So this is the reason why we got this pi. So this 14 is not exact value, right? This is a small portion of this distance, which makes the half a circle. Okay. So again, you see, so this is how we're going to measure the radians, and 180 degrees is going to be proportional to the pi radians. Okay, so again, we're measuring the same angles, and we can just change the representation of the angles from the degrees and the radians from degrees using this equation. So essentially, for example, if you're given the angle, like let's say 90 degrees, and if you would like to know what is its radian representation, you need to do the proportions. So you write down, hey, I know that 180 degrees is equal to the pi radians, and now I'm going to just make the proportions by just multiplication. I can find that x times the 180 degrees is equal to the 90 degrees times the pi, right? Then from here, I can find that the x is equal to 90 degrees divided to the 180 degrees times the pi, which is going to be equal to the pi over 2, right? I mean, that was clear from the beginning, right? Because 90 degrees is just half of the 180 degrees. So that's why x is going to be the half of the pi, okay? So let's make a table to write down the representations of some angles. So I'm going to put the table here, and we'll try to fill the table. So let's say you're given the radians, the angle here, which is equal to the 0 radian. So essentially, its degree representation is going to be equal to the 0, right? So now, if the radians is given pi over 6, so let's do this, pi over 6, what is going to be degree? And again, if you remember, the pi is equal to the 180 degrees, right? From here, you can find that the x is going to be equal to 180 degrees multiplied to the pi over 6, and all of this thing divided to the pi, okay? So it's going to be equal to the 180 degrees divided to the 6, which is going to be equal to the 30 degrees. So I'm going to write down here, oops, sorry. So I'm going to write down here the 30 degrees. This is 30 degrees, and here I'm going to write down the 30 degrees. So now let's continue. So let's say you are given pi over 4. So if you're given the pi over 4, and this is the x, so this is the pi, what is going to be this representation in terms of the degrees? So, and again, I'm going to solve this in the same way by making the proportions, right? So this multiplied to this one, pi over 4 multiplied to 180 degrees. So it multiplied to the pi over 4 divided to the pi, which is going to be 180 degrees divided to the 4, which is going to be equal to the 45 degrees, right? So I'm going to write down 45 degrees. So now we can do this in a vice versa. So let's say you are given 60 degrees and have to find its radians. So let's say you are given now 60 degrees, how to find its radian representation. And again, we're going to do the same thing. So 180 degrees is going to be equal to the pi. Then I'm going to make the proportion. So I'm going to multiply 60 degrees to the pi and divide it to the 180 degrees. And this is going to be my x. So this is going to be essentially pi over 3. So I'm going to write down here pi over 3. So let's fill down all, so fill out all of the rest of the table. So pi over 2 is exactly the half of the 180 degrees, so that's why it's going to be equal to the 90 degrees. So 120 degrees. So how to find the 120? So let's do this. So let's say we are given 120 degrees, and we need to find its radian representation, right? So I'm going to do the proportions again. So I'm going to write down the x. It's going to be equal to pi times to the 120 degrees divided to the 180 degrees, right? So I'm going to divide this and this by 60, let's say. It's going to be equal to the 2 over 3. So it's going to be 2 pi over 3. I'm going to write this down here. So this is going to be 2 pi over 3. Okay, so essentially 120 degrees can be obtained by just adding 30 degrees, right, to the 90 degrees. So essentially pi over 6 can be added to the pi over 2, and you can get 2 pi over 3 as well, right? So let me show this. Pi over 6 plus pi over 2. So if you give the common denominator here, for example, you just need to multiply this to the 3, right? It's going to be pi plus 3 pi divided to the 6. It's going to be 4 pi divided to the 6, or 2 pi divided to the 3. Or you can just find this by just making the proportions. So the 135 degrees is going to be equal to the 3 pi over 4. 4 pi over 6 can be found as the 150 degrees, and the pi is obviously 180 degrees. So you can just find the representations of the same angles in terms of the units, in terms of the degrees and the radians by just using this proportion. And please remember the definition of the radians. It is when you walk on a circle, the distance which is equal to the radiuses, right? And then you're going to, depending on how many radiuses you walk on the circle, it is going to be the measurement of your angle in terms of the radians. So thank you very much for your attention. I hope that this lecture was helpful for you.